Dear students, today we're going to tackle quadratic curves, how to plot a curve and how to use the plot of a curve. So, quadratic curves. This lesson continues from where we left about straight lines. The last part of straight lines was about how to make a table and plot a graph of a straight line. This time we're going to see how to plot a table and draw a curve. Practically we're going to do the same thing. The difference will be in how the graph will look like. But then there are a few things about curves which you need to know and which I will demonstrate to you. So I'm going to start by an example. Suppose we have to plot the graph of y equals x squared plus 5x minus 6 for values of x between minus x equals minus 7 and x equals 2. Normally you're going to have a table which looks something similar to this. You have the values of x, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, and 2. And then you need to find the value of y. Let's do table. Now there we have our table. Now as we did in the other lesson when we constructed a table for a straight line, we're going to construct a table for this. So if you have a scientific calculator which is capable of showing you a table, so choose mode or menu, choose table. For most of you it's 3. Write down the equation. Remember to input x you need to press the alpha button and close brackets. So I'm doing it right now with you. X squared plus 5x minus 6. When you press equals, if you have gx in your calculator, press again equals. You have the table range where you need to start, to stop, and the step. So this is our start. This is our end. So where you have start, type minus 7 and press equals. Where you have end, press 2 and equals. The step is how much we are each time moving from one number to another. In this case it is always 1. So where you have step, type 1. Okay, press equals once or twice and you'll get your table. My table is minus 7, 8, minus 6, 0, minus 5, minus 6, minus 4, minus 10, minus 3, minus 12, minus 2, minus 12, then minus 10, minus 6, 0, and 8. Now, the first important part of this. When you have a curve always has either a maximum or a minimum. I'm going to discuss this in a few moments, but as you can see here in our table we have symmetry. 8 and 8, 0 and 0, minus 6 and minus 6, minus 10 and minus 10, minus 12 and minus 12. Each curve should have a minimum or a maximum value, so we should have a value between minus 12 and minus 12, which gives us a minimum. You need to find a table. So what are we going to do? I'm going to take this value here, which lies exactly midway between minus 3 and minus 2. And what is between minus 3 and minus 2? Midway between, there's minus 2.5. There is minus 2.5. So what am I going to do? I'm going to take my equation, y equals x squared plus 5x minus 6. And instead of x, I'm going to write minus 2.5. So I have minus 2.5 squared plus 5 times minus 2.5 minus 6. I worked it out. and I get a value of minus 12.25. And now that is my minimum. It's very important to have a minimum or a maximum. It's very important. If when I constructed the table, I already had a minimum or a maximum, then this part here would not have been done because it would have been useless. So once I've got the table, I need to plot my graph. Now I need to pay attention to the scale I'm going to use. So before starting to plot, I suggest you do the following. You write what is the range for the x-axis and the range for the y-axis. Range for the x-axis is between minus 7 and 2. That's between minus 7 and 2. And range for the y-axis is between minus 12.25, which is the smallest value, up to the largest value of 8. So this is between minus 12.25 and 8. It's very important to know the range, because otherwise your graph won't be correct, okay, and won't be accurate. So I'm going now to plot that graph. So I have from minus 7 to 2, and from minus 12.25 to 8. So let's see this. Okay, so I have 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, 1, and 2. That's my x-axis. Now that my graph paper is landscape, yours would be portrait, okay? So yours would be would look different than mine, but still you can do the same thing. So I have 4, I have 8, I have minus 4, minus 8, minus 12. Okay? Now I am going to plot the graph. So I had minus 7, which was 8. So that's my 8. I have minus 6, which was 0. Minus 5 with minus 6. Minus 4 with minus 10. Minus 3 with minus 12. Minus 2.5 with minus 12.25. Minus 2 with minus 12. Minus 1 with minus 10. 0 minus 5. 1, 0. And 2, 8. Those are our coordinates. I am now going to draw the curve. I have technology which helps me. In your case, you need to be very, very accurate, okay? So in your case, you need to be very accurate. So that's my graph. That's my curve. That is the graph of y equals x squared plus 5x minus 6. Now, what is important about that curve? These are the important things. First of all, each curve, I told you, has what we call a minimum point. Each graph has a minimum point. In our case, the minimum point lies at the coordinate minus 2.5, comma, minus 12.25. That's our minimum. sometimes you only ask for the value of the y, for the value of y of the minimum, okay? Now, also, our graph has two important sets of coordinates, which are the place where the graph meets the x-axis. This is called the solution of the equation, sometimes also called the roots. Okay, so solution of equation is the point where the graph meets the x-axis. Okay, where graph meets x-axis. Again, these are two very important points. Another important point is the y-intercept. So that is the y-intercept. And note that in the equation, the y-intercept is minus 6. Okay? The y-intercept is minus 6. We could note that from our equation. So what we have learned up till now, we have the minimum, we have the solution of the equation. So if you are asked to solve, suppose I tell you solve x squared plus 5x minus 6 equals 0, you look at these 2 points and you tell me x is minus 6 and x is 2. Very, very important. Now sometimes also you will be asked to draw lines on this curve. For example, the line y equals minus 4. You draw the line and you will be asked to find the solution. Okay, you will be asked to find the solution. Maybe we can make another example just after this one. So that's practically what you need to know. Our graph has a smiley face shape, alright, has a smiley face shape because it is a positive curve. I'm going to write it down after this slide. If it had a sad face shape, it would have been negative, okay, because when you said something negative surely has occurred. So we say that a negative curve has this shape, a positive curve has this shape. So let me write down this. There are two types of quadratic curves. The first one is called a positive curve. It has a minimum. It has this shape. Remember, something positive is fun. The second one is a negative curve. A negative curve has a maximum. It has this shape, and remember that something which is negative is not fun at all. Okay, so those are our two types of curves. As you can notice also, I already told you this when we did the table. As you can see, the curve has symmetry, alright? You can fold along the line x equals minus 2.5. In fact, x equals minus 2.5 was the point which we needed to find the minimum point. Okay, so let's do now another example. Continue the table and plot the curve y equals minus x squared minus 3x plus 4 for values of x between minus 6 and 3. From your graph, find number 1, the coordinates of the minimum point Number 2, the solution, sorry, of the maximum point here. The solution of the equation minus x squared minus 3x plus 4 is equal to 0. Number 3, the solution to the equation minus x squared minus 3x plus 4 equals 5. Okay, so those are our 3 problems. Let's start by making up a table. So table x, y, x minus 6 is 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. As usual, you need to write down the table, the equation. So you have minus x squared minus 3x. You can do this with me right now. Okay, using your calculator, plus 4. Start is minus 6, end is 3, and step is 1. So we have our table. This is minus 14, this is minus 6, this is 0, this is 4, this is 6, again this is 6, this is 4, 0, minus 6, and minus 14. Again, please note that we have 2 maximums. So we need the midway value, that's minus 1.5. Remember how we did that? We substituted minus 1.5 instead of x. So I have the equation which is minus x squared minus 3x plus 4. I'm going to substitute minus 1.5 instead of x, so I have minus 1.5 squared minus 3 times minus 1.5 plus 4. I worked it out and the answer is 6.25. Okay, so this is 6.25 and that has to be plotted on our graph. We're going to plot the graph. Before plotting the graph, we're going to see the range of values. So range of x is from minus 6 to 3, and the range of y this time is from minus 14 to 6.25. So that is going to be our graph. Okay, so let's draw the graph now. So I have from minus 6 to 3 and from minus 14 to 6.25. So I have 0, minus 1, minus 2, 3, minus 4, minus 5, and minus 6. 1, 2, 3. I have 2, 4, 6, 8, and minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14. Now I can plot my graph. So I have minus 6 with minus 14, minus 5 with minus 6, minus 4 with 0, 3 with 4, 2 with 6, minus 1 with 6, minus 1.5, it was 6.25, 0 with 4, 1, 0, 2 minus 6, and 3 minus 14. There we got our curve. I'm going to draw the curve. restart because I clicked twice. There is our curve. Okay, you have to be very smooth because otherwise your answers won't be that good, man. So, okay, let us now answer our question. So, our questions first of all was the coordinates of the maximum point. We have found that coordinate there. Okay, so the answer to the first one is minus 1.5, 6.25. So that's very important. If we don't find that, we can't get that problem correct. The solution of the equation. I said that the solution of the equation lies where the graph meets the x-axis. It meets the x-axis at -4 and at 1. So we've got x equals -4 and x equals 1. The last one, the solution to the equation minus x squared minus 3x plus 4 equals 5. Now, as you can see, minus x squared plus 3x plus 4 is the same as this. The difference here was equal to 0, here it's equal to 5. So what do I need to do? I'm going to go on the graph. Find y equals 5. Draw a line where y is equal to 5. And see where that line meets the curve. As we can see, that line meets the curve at these 2 points. One is minus 2.6, the other is minus 0.6. So I can say, okay, so this is minus 2.6, this is minus 0.6. So I can say that the answer to that problem is x equals minus 2.6 and x equals minus 0.6. Okay, so this is the theory about curves. Okay, so that's about curves. We've done straight lines and now we've done curves. So this part of the topic is finished. I hope you have understood the lesson